Good morning everyone. My name is Mehtab. I am going to explain about Clausius-Mosoti relation. In this session, we learn about introduction to Clausius-Mosoti relation, formula for Clausius-Mosoti relation, what is polarization and how it acts in Clausius-Mosoti relation, and what is local field, what is the importance of local field in Clausius-Mosoti relation, derivation steps, assumptions, applications, advantages and disadvantages of Clausius-Mosoti relation, limitations and conclusion. First, what is introduction? What is Clausius-Mosoti relation? Here, Clausius-Mosoti relation is an important concept in electromagnetic and material science. It explains how the microscopic structure of the material is related to its macroscopic electrical property called dielectric constant. Formula for Clausius-Mosoti relation. Epsilon naught minus 1 by epsilon naught plus 2 equals to n alpha by 3 epsilon naught. Here, epsilon naught denotes dielectric constant, alpha is polarizability, and n equals to number density. Polarization. How it acts in Clausius-Mosoti relation. Polarization connects microscopic dipoles to macroscopic permittivity. It shows that more polarization indicates higher dielectric constant and less polarization indicates lower dielectric constant. Next one is local field. First we have to learn about what is local field. Local field is the actual dielectric field experienced by an atom or molecule inside a dielectric material when an external electric field is applied. Here, field acts inside dielectric, different from applied field, includes neighboring effects given by EL is equals to E plus P by 3 epsilon naught is the formula for local field. It is very important in derivation. We can use this formula in so many derivations. Derivation steps. Start with dielectric in field. Find local field by using the formula EL is equals to E plus P by 3 epsilon naught. Use P equals to N alpha EL. By substituting EL, we will get the final equation. We have to simplify until we get final equation. Assumptions for Clausius-Mosoti relation. Material is isotopic. Here, non-polar molecules are applied. Low density medium. It behaves linearly. It doesn't have any interaction forces. Applications of Clausius-Mosoti relation. It is used to study dielectric materials. It is also used in optical properties. It has refractive index relation. It is helpful to find the relation of refractive index. It is used in material science and also in physical researches. Limitations for Clausius-Mosoti relation. It fails to explain dense materials. It doesn't have polar molecules. It ignores interactions. It is useful only for approximations. It has a limited accuracy. Advantages of Clausius-Mosoti relation. It gives actual field. It improves the real electric field acting on molecule inside a dielectric. It links micro and macro properties. We have already learned this in introduction part that Clausius-Mosoti relation is useful for both micro and macro properties. Connects molecular polarization with macroscopic properties like dielectric constant. It is very useful in Clausius-Mosoti relation. Disadvantages. It is based on ideal assumptions. It assumes a perfectly uniform and symmetric structure like cubic, which is not true for all materials. It doesn't suit for all materials. It doesn't have accurate for all materials. It does not work well for non-isotropic or irregular structures. It works only for dielectric materials. It ignores complex interactions. Conclusion for Clausius-Mosoti relation. It links polarizability with dielectric constant. It shows how polarization affects materials. It explains the behavior of dielectric materials. It is useful in capacitors and insulation designs, important in physics and engineering. It determines how much a material becomes polarized in an electric field. It connects the microscopic properties. Hope you are all understand this concept. Thank you for giving me this opportunity.